All right, hey everybody, sorry I'm gone again. I just had a doctor's appointment, but I don't want you, this 7th period class, to be behind, so I need you to get out M4L1, and we are going to go through the video portion of what we did in the other two classes today. And then whoever is videoing this, subbing for me, thank you, but then also just make sure that you pause it whenever the students need a little bit more time, or if I give work time, and then just push play once you're ready to continue. So you have M4L1 out in front of you. If you need to pause it now to get that out, please do. All right, so you should have M4L1 out in front of you, and I need you to change to, we ended last Friday on this, the homework for you guys was to complete the back here of your page, exercises 1 through 4. So this is the key if you want to see if you got everything right. Again, you can pause it. And then what I want you to start off with is now on the next page here, Introduction to Basic Factoring. So make sure you're at this page. First, quick, we just have some vocab reminders. We have polynomials, remember that just means many terms. Trinomial specifically means 3 terms. And we have the standard form of a polynomial, of a trinomial, ax squared plus bx plus c, where a, b, and c are just numbers. And factored form of a trinomial, which is an example, obviously a and b would be numbers, but this is what factored form would look like. So here's example 1. Below is a completed area map. In order to factor trinomials, we need to decide how to reverse the order. So we have been practicing this whole time how to start at factored form and get into standard form. We know how to use multiplication to be able to figure that out, standard versus, or factored to standard. But now by the end of today, I want you to be able to say, I know how to now start in standard form and reverse back into factored form. So it's essentially like what we've been doing, filling on the outsides, but I want us to be able to go from standard form to factored form without having to use a box, and without having that be given to us. But first I want you guys to take a couple of seconds, and I want you to answer this question here that I've starred. What do you notice about the relationship between 7 and 3 and 10 and 21? What do you notice about the relationship between 7 and 3, 7 and 3, and your final 10, the B, and 21, the C? B and C. Take a minute, write down a complete sentence. My hint might be, what's 7 plus 3? So once you've gotten that, you should have complete sentences here. The relationship that you should have seen is the relationship, you should be writing if you don't have this down, between 7 and 3 and 10 and 21 is that 7 plus 3 equals 10. You should have recognized that 7 plus 3 gets you 10, which is the B term. And 7 times 3 gives you 21, which is the C term. So this is a special relationship that we're going to continuously use actually through all of Module 4. And it's a huge deal in your region, so just be sure that you're understanding as much as you can today. We're gonna have more practice time on this, but this is really your intro day to factoring. The big takeaway is that these two numbers add up to your B, but also multiply to your C. So these are actually what I'm gonna call, you'll hear me say this a lot, is these are your 2 magic numbers because of this special relationship that they have with B and C. They can create B and C, just changing addition and multiplication. So if you look at that, we have 7 and 3 here because I want to multiply them to get 7x and 3x to add together to get your b term of 10x over here. 7x plus 3x is going to get me my b of 10. But then I also know that if I multiply them, my end box here is going to get me 21, which is what I want for my c. Now, if we didn't have this box here and we weren't given the magic numbers, this problem really is done for us, so we know it's 7 plus 3, but if we weren't given the magic numbers, we're going to do something called an ACB chart to find it. So this ACB chart goes a little something like this. You should definitely be writing this down because it's something you're going to use regularly to find your magic numbers. So if we weren't given our magic numbers, we would just be looking at this here and being asked to factor it in standard form. So I would first want to label what's my a, what's my b, and what's my c. So if we remember, standard form is ax squared plus bx plus c, a being the number in front of the x squared term, b being the number in front of the x term, and c just being the number that's alone. So if I look here, I know that a is with the x squared term. There's no number in front, so that means that my a is just the imaginary 1. It's not x squared, it's just a number, it's 1. B, the term, is 10x. The b value, that means, is 10. And c is just 21. So we're going to make this ACB chart. So a times c, and then b goes over here. So in order to find our magic numbers, we're always going to do this strategy. We're going to multiply the a and the c together after we've labeled them. So 21 times 1 is just 21. We're going to just write down what b is. B is 10. And then we're going to make some symbols here. I'm going to zoom in here. I'm going to write times down here and plus over here, because whatever numbers I choose need to multiply to 21 and add up to 10. So I'm then thinking about, okay, what numbers get me 21 as factors? 21, what do I get multiplied to 21? There's 21 times 1, there's 3 times 7, and those are the only chances we've got. Those both qualify for multiplying to 21. Then I need to choose the factor pair that also qualifies that we add them together, we get 10. So 21 plus 1 is 22, so that's not going to work. 7 plus 3 is 10, so that is now going to work. That means I know my magic numbers are 7 and 3. 7 times 3 is 21, check. 7 plus 3 is 10, check. So now I know those two are my magic numbers, and I'm just going to fill them into my factored form. So if I were going to take these numbers, 7 and 3, and I was going to create the factored set myself if I didn't know it, I would know it was positive 7 and positive 3 as my factor pairs. It also doesn't matter if I wrote 3 first. The order doesn't matter when multiplication. And then I know that I need an x squared, so I need x times x. Now, how would I know what to do if I wanted to check if this was correct? I want to check if this is indeed the same thing as x squared plus 10x plus 21. Then, if I wanted to check my work, I could just create the box and work backwards. X plus 3, x plus 7, x squared, 3x, 7x, 21, and make sure I was correct. X squared is by itself, 3x and 7x combined is 10x, and 21 is alone. So I would get x squared plus 10x plus 21, and I'm good to go. That's my check. Now you don't need to do that every single time, but I do need you to understand that this value here and written in standard form, they're equal. They mean the exact same amount. It's just a different way to write it. This is standard form, this is factored form. So we're going to do the same thing in exercise 2. It's given to us, but you need